Good morning everyone. Today, I'll be talking to you about acids and bases and their various characteristics and reactions. Acids and bases are a vital part of everyday life, from the food we eat to the products we use. Let's begin with an overview to better understand why they are so important. Acids are substances that release hydrogen ions when dissolved in water, while bases have a pH above 7 and release hydroxide ions when dissolved in water. Acids are usually sour, whereas bases are typically bitter. They both can react with other substances to cause changes in the environment. Acids are generally corrosive, while bases are not. Acids can be used to neutralize bases, and bases can be used to neutralize acids. Both can be used to produce chemical reactions and to create new compounds. Understanding the properties and reactions of acids and bases is essential for scientists, chemists, and many other professionals. Acids are vital chemical substances which can be encountered in various elements of our day-to-day lives. These acids can be distinguished by their sour or bitter tastes and their slippery textures. When added to water, these substances release hydrogen ions which combines with chlorine ions to form a compound. Illustrative examples of acids are hydrochloric acid and sulfuric acid, both of which are highly reactive and often utilized in the laboratory. Acids are potent substances with various functions. When mixed with water, strong acids dissociate completely and produce hydrogen ions, or H+. These can integrate with the water molecules and form hydronium ions, contributing to the sour taste and slimy feel of acids. Typically, strong acids are identified by their chemical formulae, which normally contain hydrogen, sulfur and oxygen. Weak acids only dissociate partially, releasing fewer hydrogen, H+, ions compared to strong acids. This is why some acids have lower pH level than others. Strong acids have a pH level below 7, while weak acids usually have a pH level higher than 7. Acids are characterized by their sour taste, reaction with metals and carbonates to produce gas, and presence of hydrogen. They play an essential role in a variety of reactions and processes. Acidic solutions have a pH lower than that of plain water, leading to the sour taste. They can be found naturally as well as in food and beverage, certain cleaners, or a variety of industrial products. Acids can be corrosive and hazardous, hence it is important to handle them cautiously and observe all safety protocols. Acids are known for their sour taste and their various effects on the skin. Eating acidic foods such as citrus fruits will give an individual an idea of how an acid behaves. In addition, acids can produce a burning or prickling sensation when in contact with skin. These properties make acids recognizable and useful in many ways. Acids have a range of distinguishing features, including a sour or bitter taste, slippery feel, production of ions, and the presence of hydrogen. Since tasting or touching an unfamiliar chemical is highly hazardous, we can't use this method to determine whether a solution is an acid. We can instead measure the pH of the solution, or observe the reactions it has with other compounds, as well as its color, transparency, and fragrance. All of these characteristics help us to distinguish acids from non-acids without having to taste them. When an acid is present in a solution, it can be detected by placing a few drops onto a compound containing a carbonate, for example, limestone. Limestone consists of calcium carbonate, and when acid comes into contact with it, a reaction occurs in which carbon dioxide gas is produced. It is important to understand the reaction of acids with metals when discussing the characteristics of acids. Generally, acids will react with metals to produce hydrogen gas, visible as bubbles. This reaction is essential to comprehend how acids and bases interact and their different properties. Acids possess particular characteristics that separate them from other solutions. They consist of hydrogen, and when in contact with other compounds, they release hydrogen ions, bestowing them a sour or bitter taste and a slippery feel. Acids can also give off certain ions when joined with a base, creating drastically reactive solutions. Furthermore, when looking at chemical formulae, acids continuously contain hydrogen at least once. Base releases hydroxide ions in an aqueous solution. An example would be when sodium hydroxide, NaOH, is dissolved in water. The compound splits up into separate sodium ions, Na+, and hydroxide ions, OH. Such reactions can be utilized in various ways, and they carry potential health and safety risks. Bases can vary greatly in terms of taste and texture. They are generally bitter and have a slippery feel. On the chemical level, they contain hydroxide ions, represented by OH. This knowledge of the properties of bases is fundamental to understanding the basic concepts of acids and bases. Bases are recognizable for their bitter taste, such as baking soda. This is due to the properties of bases including the releasing of ions with hydrogen and a slippery texture, all of which give the bitter taste. It is not advised to rely on taste or texture when identifying if a solution is a base or an acid. Even though mild bases in foods may have a bitter taste and a slippery feel, stronger bases can be as corrosive and dangerous as strong acids when it comes to burning the skin. Therefore, it is essential to use reliable testing materials and techniques when determining if a solution is a base or an acid. Base compounds possess particular characteristics which make them unlike acids, like a slippery or soapy sensation when touched. This is because when bases encounter the fatty acids present in our skin, it induces a reaction which releases ions. Bases also have hydrogen, making them a vital element in numerous biochemical processes. Base compounds often have a slippery feel to them. This is because when sodium hydroxide, the most common base, is mixed with fatty acids, it forms soap. This means that when a base touches your skin, it is combining with the fatty acids to create a small amount of soap, thus creating the slick feeling. This is one of the most useful properties of a base. Bases are chemical substances that consist of sodium hydroxide, O, and have alkaline qualities. Examples of bases are lithium hydroxide, sodium hydroxide, NaOH, potassium hydroxide, Co, rubidium hydroxide, cesium hydroxide, barium hydroxide, Bau, calcium hydroxide, and strontium hydroxide, SrOH. Their unique characteristics include being slippery to the touch, releasing ions, containing hydrogen, and having a sour or bitter taste. Acids generally have a sour or bitter taste, a slippery texture, and contain hydrogen, whereas bases typically release ions and may have an alkaline taste. Understanding these characteristics can assist us in comprehending the reactions and formulae of acids and bases. Acids and bases possess several crucial properties. They are both able to be dissolved in water, capable of conducting electricity when dissolved in aqueous solutions, and have the potential to cause irritation or even cause burning when touching the skin. In spite of their disparities, acids and bases share some common traits. Both contain hydrogen, and both release ions when dissolved in water. Additionally, both acids and bases possess a characteristic taste and slippery feel when touched. Grasping these features of acids and bases is indispensable to the exploration of chemistry. Acids and bases have distinct characteristics that can be evaluated in various ways. One such evaluation is the pH or potential hydrogen, which reflects the amount of H+ ions in a solution. To determine the strength of an acid or a base, the pH scale is utilized. The stronger the substance, the lower it is placed on the scale. The pH scale is invaluable for assessing and comprehending acids and bases. Typically, the numbers span from 0 to 14, though values outside this interval are also measurable. Of these numbers, 7 is especially significant because it stands for a neutral solution. A neutral material is neither acidic nor basic. The pH of pure water is 7, thus denoting its neutrality. Regarding acids and bases, pH is a helpful indicator for comprehending their connection with one another. Solutions with a pH less than 7 are labeled as acidic, solutions with a pH of 7 are considered neutral, and those with a pH higher than 7 are viewed as basic. Knowing these distinctions is imperative in order to precisely assess the reaction between two substances. Understanding the differences between acidic and basic solutions is important in understanding the reactions they partake in. Concentrated strong acids have a low pH value due to releasing hydrogen ions into solution, which lowers the pH readings. On the other hand, concentrated strong bases have a high pH value as they accept hydrogen ions, thus increasing the pH readings. This slide displays the differences between concentrated strong acids and bases. Acids and bases have a major part to play in science, and one way to identify them is to use acid-base indicators. An acid-base indicator is a chemical that changes color depending on the solution it is placed in. Litmus, an organic compound derived from plants, is a good example of an acid-base indicator. It can be found in red and blue, and it turns pink when placed in an acidic solution, and blue when placed in a basic solution. Through the color change of litmus, scientists can quickly spot the presence of acids or bases. The color of hydrangea flowers can vary depending on the pH levels of the soil they are planted in. If the soil is acidic, with low pH levels, the flowers will be blue or purple, while if the soil is basic or alkaline, with higher pH, the flowers will be pink or light blue. Knowing the pH of the soil is key to achieving the desired color of blooms. Accurately measuring and analyzing the pH of a solution is an important part of any acid-base reaction, but it is not possible to determine the exact pH of a solution using one indicator such as litmus. To overcome this issue, numerous acid-base indicators are used, each of which is designed to cause a color change at different pH levels. This ensures that chemists can accurately measure and analyze the pH of a solution. Acid-base indicators play a vital part in chemistry. Universal indicator is composed of certain chemicals that alters the color of a material in accordance with its pH levels. This indicator can easily determine the acidic or alkaline nature of a solution and support in calculating the exact pH value spanning from strong acidic to strong alkaline. The concept of pH, which measures the acidic or basic level of a solution, is well known. However, an even more precise measurement of pH can be obtained with an acid-base indicator. This is a chemical that changes color depending on the acidity or basicity of a solution. For an even more exact result, a pH meter can be used. It works by measuring electricity and converting it to a pH scale. Chemistry of acids and bases is a significant part of the physical world. When an acid and a base meet, their unique features are removed through their neutralization, meaning the pH of the solution is balanced at 7. This reaction is referred to as neutralization. When two acid or base solutions react, the products formed are known as salts. These salts can either be soluble in water, dissolving to form a solution, or insoluble. When the salt is insoluble, a precipitate is formed. A precipitate can be defined as a suspension of solid particles created from a chemical reaction. Acid and base reactions are fundamental in chemistry. The general formula is that an acid reacts with a base to form water and a salt. To illustrate, HCl, hydrochloric acid, and NaOH, sodium hydroxide, will create H2O, water, and sodium chloride, sodium chloride. Keep in mind that salt refers to any ionic compound formed, and not just sodium chloride. Acids and bases are often linked to reactions that balance each other out. An example of this is when antacid tablets are used to ease an agitated stomach. Our stomachs produce hydrochloric acid that has a pH of roughly 1.5. Taking the antacid neutralizes the acid, settling the stomach. When it comes to acids and bases, neutralizing each other is an important reaction. An antacid tablet contains a base such as sodium bicarbonate, magnesium hydroxide, or calcium carbonate. When this base reacts with the acid in the stomach, it produces a salt and water, and lowers the acidity in the stomach to its normal value of around 2. Understanding this topic is important, and we hope this information helps. Thank you.